Video, I'm going to be working Algebra 2 Quiz 10.1. So we're just going to be simplifying some rational expressions and I think solving some rational equations. So first one is simplify, and if it's multiplying two fractions, we're going to just multiply it straight across. I might start by factoring the top because I think that's going to be x minus 2 times x plus 1 divided by, maybe I'll just multiply them all at once, 3x squared multiplied by x plus 1. And I've got a 6x to the 4 on top. Okay, so I can cancel the x plus 1s. And the 6 and the 3, I can cancel that off to make a 2 and a 1. And then x to the 4 divided by x to the 2, that's just x to the 2 in the numerator. Okay, so I'm left with a 1 in the denominator and a 2x squared times x minus 2 in the numerator, so you could stop there, or you could distribute it if you felt like you needed to, and that would be 2x cubed minus 2x to the 2. Number 2, another simplify, but this one's addition and subtraction. I might make this a little bit bigger. Alright, so if we're simplifying this, we're going to need a common denominator. So I've got 2x minus 10 over x squared minus 9, which I could write as x plus 3 and x minus 3. And then I'm going to subtract x plus 4 over x plus 3. But if I want to do this, I need a common denominator, so I need to get that x minus 3 in there, multiplied on top and bottom, so I'm not changing the fraction. And then this will equal 2x minus 10 over x squared minus 9, minus, okay, and if I distribute the x minus 3 over the x plus 4, I'll have x squared plus 4x minus 3x is going to be plus 1x minus 12, all divided by x squared minus 9. Okay, and if I subtract all of this, taking 2x minus 10 and subtracting an x squared, an x, and a negative 12, I'll have a negative x squared. I'll have 2x minus 1x, and negative 10 minus negative 12, that's positive 2. Now this numerator can be factored, I remember from the other time I worked this, but although it can be factored, there's not any common factors with the denominator, so there's no benefit to factoring it, so I'm just going to leave it there. Be happy. Okay, number 3 is asking for the values of x that make the equation true and asking us to show our work. Okay, we're going to do cross multiplication here, so I'm going to say 2 times x minus 1 equals 1 times 3x. So that would be 2x minus 2 equals 3x. I might subtract 2x from both sides and get negative 2 equals x. On to the back, number 4 says find the values of x to make the equation true. Okay, so this one is a little bit different. I'm not going to be able to just cross multiply. I think what I'm going to try for is to get a common denominator on all 3 of these terms and then just clear out that common denominator. So I think that common denominator will be 3x, x, and 12. That would be 12x. Alright, so x over 12, I'm going to need to multiply that by something, plus x plus 3 over 3x, also going to need to multiply that by something, equaling 1 over x. So I guess all 3 of these are going to need to add on. So I'm going for 12x in the denominator, so I need an x on the first thing. The second thing, I would need a 4 to get from 3x to 12x, and then on the third thing I would need some 12s. But notice that all these fractions in blue, these are just equivalent to 1, so I don't have to worry about, changing the value of the fraction. That's what I'm always worried about. So I have an x squared over 12x plus, okay, I'm going to need to distribute the 4 over the x and the positive 3, so it would be 4x plus 12. And that's going to equal 12, oh wait, no, it was an x squared over 12x. Now that I've got a common denominator to all of these things, really what I'm doing is I'm multiplying both sides by 12x, and that's going to clear out those denominators. And so then I get x squared plus 4x plus 12 equals 12, so that means that x squared plus 4x is equaling 0, right? If I subtracted 12 from both sides of the equation that was left. And then I can factor this and get x times x plus 4 equaling 0, and get either x is equal to 0 or x plus 4 is equal to 0, which would be where x is negative 4, and I have to go back and check for possible extraneous solutions. And when I'm plugging in x equals negative 4, no problem there, I'm not ever dividing by 0, but if I use x equals 0, that is going to cause me to divide by 0, and I'm going to say that's extraneous. Now some inverse variation. Been a while since I've seen any of these. So if x and y vary inversely and x is 4 when y is 10, write an equation that relates x and y. Alright, so in general, inverse variation is y is some number divided by x. They're telling us x is 4 when y is 10, so I'm going to just solve for the value of k by plugging in on x and y. And I'll multiply both sides by 4 to see that k is equal to 10 times 4, which is 40. So my equation that relates y and x would be y is equal to 40 divided by x. Now the last one on Form A is if a and b vary inversely, so a is some number divided by b, and a is negative 8 when b equals 3. Okay, so I'm going to multiply both sides by 3 to find the value of k, and I'll see it's negative 24. So a equals negative 24 over b. Find the value of a when b equals negative 2. So a will equal negative 24 divided by negative 2, and that's going to be 12. All right, now Form B. We're just going to start back over, simplify the rational expression. So if we're multiplying two things straight across, we can start by factoring, or we could multiply and then factor. It's all the same thing. So two numbers that multiply to negative 6 and add to 1, that would be 3 and negative 2. And I'm multiplying by a 6 and an x to the 4. Now in the denominator, I've got a 2 and an x cubed. Maybe I'll put the 2 here and the x cubed right there, and an x minus 2. So I'm going to cancel off the x minus 2's. I can say 6 divided by 2 is the same as 3 over 1, and x to the 4 divided by 3 is like x over 1. Right? Subtract the exponents. So really what I've got is a 3x. I don't understand why these things are just disappearing on me, but a 3 and an x multiplied by x plus 3, all divided by 1. Well, that's just no need to divide by 1. Or I could distribute it if I wanted to and call that 3x squared plus 9x. Number 2 is also asking us to simplify this expression, but we're going to need a common denominator first. So I'll have 3x minus 10 over x squared minus 16, which I might call x minus 4 times x plus 4. Minus x plus 3 over x plus 4. Okay, so I'm going to need to multiply on top and bottom by the same thing to get that common denominator. What I'm missing is an x minus 4. Okay, so I'll say that's 3x minus 10 over x squared minus 16. Minus, okay, if I was to distribute, I'd get x squared plus 3x minus 4x minus 12. Wait. Plus 3x minus 4x is not going to be minus 4x. It's going to be minus 1x. Divided by x plus 4x minus 4 is x squared minus 16. And if I'm subtracting all of this stuff, okay, I'm going to have 3x minus a negative x is 4x. I'm going to have a negative x squared, and negative 10 minus negative 12 is plus 2. Okay, it's probably not written in the most standard form ever, but it will work. I just want to show you that that's an option you've got too. So I'm just checking all the things. Okay, an x squared, so it's got negative 1 of them. 3x minus a negative x is 4x, and 10 minus negative 12 is 2. Okay, I feel good about that. All right, number 3, we're going to find the values of x to make the equation true, and we're going to be able to find that by cross-multiplying. So 5 times 4x plus 1 is going to be equal to 3 multiplied by 2x. So 5 times 4x would be 20x, and 5 times positive 1 would be positive 5, and that's going to equal 6x. I'll subtract 6x from both sides. And then in order to get at the x, I'm going to need to get rid of that plus 5, so I'll subtract 5 from both sides. And then x equals negative 5 divided by 14. That's not going to be an extraneous solution because I plug that in. That's not going to cause me to divide by 0. All right, number 4 is another equation solving situation, but this is one where I'm going to get a common denominator to all 3 of these fractions and then just, multiply both sides of the equation by that common denominator to just clear it all out. So I'm thinking I'm going to go for a common denominator of 18x. Okay, so x over 18 plus x plus 6 over 9x is equal to 2 over 3x. And I'm going to need to multiply all this stuff by something else. I'm going to just be careful with my parentheses. And then I'm going to say, okay, what is each thing missing? All right, I'm going for a common denominator of 18x. So I need an x down here, so I got to be fair and add the x up there. 9x I would need to multiply by 2 to get to 18x. So I'm going to need 2 on both sides, and then 3x, that needs a 6. So I'd have it like that. And then I'd say, all right, that means x squared over 18x plus, okay, distribute the 2 over the x plus 6. That's going to equal 12 over 18x. Now that I've got the same denominator on all the terms on both sides of the equation, I can clear out that denominator and say, all right, now I've got x squared plus 2x plus 12 equaling 12. I could subtract the 12 from both sides and say, all right, that means x squared plus 2x equals 0. I could factor out the x and say, all right, that's going to be equal to 0 whenever either of those two things would equal 0, which would be if x was equal to 0 or if x was equal to -2. But now I need to check for extraneous solutions. Something I need to be worried about would be an x that would cause either of these things to come back 0 in the denominator, and x equals 0 does cause that, so I'm going to need to get rid of that. Get rid of x equals 0, and I'm going to say that's extraneous. The last two are just some inverse variation situations. So the first one's asking for an equation that relates x and y. So if they tell me that x and y vary inversely, that means automatically that y equals k divided by x, where k is just some number that we can find given just a little bit of information. So if they say x equals 4 when y equals 9, I'm going to say 9 is equal to k divided by 4, and I can solve for k. So multiply both sides by 4, and I'll say 9 times 4 is 36, is equal to 4k over 4, though that's just k. I've got k equals 36, so my equation relating y and x is y equals 36 divided by x. And the last one I've got is a and b are varying inversely. Okay, so we know that means a is some number divided by b. And a equals -8 when b equals 5. Multiply both sides by 5 and say -40 equals k. So a equals -40 divided by b. And we're finding the value of a when b is -2. Okay, well, so a is going to equal -40 divided by -2, which is going to be +20. And well, that's going to be all for this quiz. Thanks for watching.